with initial velocity v bar equal to v naught j cap in the presence of e bar equal to e naught I cap and b bar equal to b naught I cap. Find the possible trajectory. Okay, now I'm bringing the some electric field vector also, and we know the particle will experience electrostatic force. So here it's going to describe an helical path with increasing pitch. And there's a rough diagram. You can see the pitch. I'm keep on increasing it. So you take this distance, P1, P2, that will keep on increase here. So this is P1, P2, P3, P4. So we can write so along x-axis, what type of motion? Because of electrostatic force, accelerated motion. In y minus z plane, it's going to describe a uniform velocity motion, uniform circular motion. So let's break up this problem again into the axis like y minus z plane. So the best way of trying to get that one. So rather than the 3D diagram, no, so you can prefer this. Rather than 3D diagram, you can prefer this one. So this is y minus z plane. So it's going to revolve in a circular path. So again, how the b bar will be? B bar will be out of the plane. B bar should be the out of the plane. Because along x-axis will be out of the plane of paper. And the charge particle is going to, so you can ask me a question, sir, why only like this? On what basis you are drawing this diagram? Like any specific reason? I'll take help of the basic again. The charge particle is given velocity. It's a positive charge particle. Clear this. The charge particle is positive. Oh.
Yeah.
Okay, then I'll do it some. Screen share. Visible? Huh?
Yes, sir.
I think we have lost it. It's not getting. Yeah. Oh. Let me redraw it. So it will be 1, 2, 3, 4 lines. So this will be the pitch P1, P2, P3, P4. This is a circular path. The particle here velocity. This will be the b bar minus z plus y. This is the radius, you write it. This is r. The same similar like, so you look at the force, or the force F will be acting like this. This is the magnetic force. So better write FB, because there are two forces are there, magnetic force and this one. So again the same method, due to V naught, this would be the condition. So it's going to revolve in circular path in y minus z plane. So what is the plane of circle? Plus or minus, in which plane the particle will describe circular path, plus or minus y minus z plane. What is the axis of helix? Axis of helix is parallel to x-axis. So, and what is the pitch? Pitch is going to increase here. So the radius depends on what all? Radius depends only on that initial velocity of projection, what we have given. V naught by B alpha. So many other things are there. So what about the time period of revolution? Will it be constant? So will it describe uniform circular motion y minus z plane? No, non-uniform circular motion. Time taken to complete the revolution will be different in different things, no? So at t equals 0, it is projected. Then after some time, so after every one revolution is going to come in. We are neglecting electrodynamic. Accelerating charge particle will produce electromagnetic field. There's a dynamic one. What we are discussing is magnetostatics. So goodbye to all that one. Huh? So we don't discuss anything electrodynamics. What we are having, electrostatics, magnetostatics, finish all. And also the field produced due to moving charge particle also should be avoided. That's why we have kept now. If I teach first Biot-Savart law, in the Biot-Savart law, what you're having, moving charge particle also will produce magnetic field. Even that magnetic field will come into picture. What we're discussing again on a paper, we are in paper world. In the realistic, so the moving charge particle also will produce magnetic field. That magnetic field and the external magnetic field, there'll be interaction. Things will change a little bit. So time being, so don't go for any dynamics, or moving charge particle will produce any field. So there's no such field it will produce. Time being, the whole this week. Fine. Now this is about the thing. Not doing wrong. We are just studying the part wise. First you learn this. Next week, Alton, you bring that field. Next, after EM waves, bring electrodynamics. Like that, you keep on learn stage wise. At a time, you can't learn all. You have to learn stage wise. Okay, this is about the radius. We got it. So then, what about the x coordinate? Y coordinate, again the same equations like what we did earlier, no? The same method what you can bring it here. Okay, I'm interested to get the velocity vector. After some time,
Yes, sir.
it will be here. So it will make an angle. Theta, let me take theta, no problem here. So here the particle will have velocity V naught in YZ plane only. It will also have one x component of velocity. So this should be this will be theta, this will be theta. Okay, let's come for all. First x coordinate will bring it here. What is the x coordinate should be equal to? Acceleration along x-axis by t square. No? What is the acceleration along x-axis? QE by m. T square. T square is what? The particle will touch the x-axis after one revolution. Am I right? The particle will touch the x-axis after every one revolution. So here, so what is the time taken? Time period of revolution. Time period of revolution is same thing. How much it is? 2 pi m by bq, or 2 pi by b alpha. So after one time, the particle will be here. At t, it will be here. At 2t, it will be here. At 3t, it will be here. At 4t, it will be here. At 5t, it will be here. After every one revolution, what will happen to particle? Particle will come and touch the x-axis. What are that? And t equals 0, it will be there. T equals at origin. After every one revolution, the particle touches the x-axis. Here, this is what happens. T equal to 0. After one revolution, touches x-axis. again after one touches x-axis here. So shall I write now t in terms of nt only? Okay, and what is the time period of revolution? Substitute this value, you are going to get the x coordinate. What about y coordinate? Again, the method is same. Like just now what we discussed previous one, the same y coordinate you can apply it. Y equal to r sine theta. And what is r? V naught by b alpha. You can ask one thing, sir, why you are not taking, because speed of particle will increase here, no? So omega should be equal to b alpha. Now why we are, this how we can still write v naught in yz plane. What happened to speed of particle will remain v naught. Along x-axis it is going to increase. Z coordinate again same thing, r minus r cos theta. Okay, later on you do substitution. Okay, anyway, let me write here. The same thing just now what we discussed is what I'm putting here. So even for helical path with increasing pitch, if electric field. Now let's come for the velocity vector. So what you write expression for velocity vector? V bar equal to Vx I cap plus Vy j cap plus Vz k cap. What is Vx I cap? Should be equal to Ax into T. What about Vy? V naught sine theta G. So this should be plus V naught cos theta k cap. Earlier it was phi, now I took theta. Symbols are changing, you have to be careful. Where all omega is there, you can replace. And omega equal to what? B alpha. What is Ax equal to? QE by M T. V naught is a constant sine theta. Every problem try to check position vector as well as the velocity vector. So this is the expression for the velocity of the particle at any time t. Okay, fine. So look at this one. So this is, shall I say, helical path with increasing pitch. What is the name I'll give? Helical path.
So minus Vz.
No, that time will determine, no? Like previous problem only we have seen, no? The value of t will determine will be positive or negative. Just put it because it's an algebraic sum, no? Just no previous problem. Okay, okay, this one we took negative. Yeah. It can be positive also. It all depends upon the time. Okay, no, this is about the velocity, this one. So few questions like what actually, how the particle will cross that x-axis. There are two velocities are there. No, one v naught will be constant, other vx will be increasing. So every time when it is crossing, so what will happen to the velocity of particle? Will there be any change in orientation of it? Because x component of velocity will continuously increase, whereas yz component will remain same. So when it's crossing the x-axis, it varies instants of time. So here,
Sir, it is V naught cos beta B alpha T K cap.
okay, yeah, thank you. Okay, yeah, b naught cos theta. Oh no. This is cos, that is sine. Huh? Here, b naught cos theta j cap, b naught sine b alpha t k cap. I just made corrections, just see here at this particular point. V naught cos theta will be along y-axis, V naught sin theta will be along negative z-axis. Let's come for...
Also, same thing.
Huh?
In the, no sir, there only where you made the changes.
Yeah.
There, one step back also you have to
Okay,
change
okay.
it.
Yeah, this one, cos, no? Cos theta, sin theta. I think everywhere same, huh? Yeah. Now, look at that. When it crosses the x-axis, what will happen to the velocity vector? Will it have same orientation? Initially, t equals 0, how the velocity vector it was making. So now I'm interested in which particular, in which plane you can see that clearly now. There are two velocities are there. One v naught, other will be the vx. And what will happen to vx? Vx will continuously increase. So at t equals 0, I'll draw one line. So this is very important. You just see that this is x-axis. So what is this line? This is x-axis. And this is y-axis. So in YZ plane, what will happen to, so here instead of y-axis, let me call this is YZ plane. So what I'm plotting along y-axis, along vertical direction, YZ plane, not x, not y-axis here. I'm asking you to think like this. Why that plane only better? You write it. Now, first at t equals 0, in what direction the particle will have? Along x-axis will be 0. And what will happen to speed of particle in yz plane? Speed of particle in yz plane will remain constant, equal to v naught. And along x-axis, what will happen? Will keep on increase. So we'll agree. So here, if it is having v naught particle, after some time, so what happen? X component will increase. No, slightly it will deviate, and after some time, it will be after every one revolution. Okay, I'll have to show also pitch also. No. I'll draw a little bit big vector. And the pitch also should increase. Look at the orientation, and also the length of the vector also should increase. Now why we are showing it in this way? Because v naught velocity in the yz plane will remain v naught. And with every time what will happen, v naught and vx will keep on increase, no? And this is at t equal to 0. This is a time. This is after some time t, after one revolution, after two revolution, after three level. This is the total velocity vector. So call this is v1, v2, v3, v4. And look at the angle made by that with x-axis should keep on decrease. Any reason for that? In yz plane, velocity will be constant. But along x-axis, the velocity will keep on increase, no? Because of acceleration, qe by m. So therefore, the resultant velocity vector of pen should get inclined more and more towards x-axis. So at any time t, what is the angle made by the velocity vector with x-axis if I ask you? So this is some beta. So what is tan beta? We can write it. Tan beta, it will have two components, one Vx, other V naught. Tan beta should be V naught by Vx. And what is Vx equal to? Qem by T. Acceleration along x-axis. And look at as T increases, T what when you substitute in terms of Nt. T equal to Nt. N equal to 0, N equal to 1, 2, 3, 4. Able to analyze the situation. The x component of velocity keeps on increases. The speed of particle in yz plane, it remains constant. When it crosses, whenever it is crossing x-axis, how the velocity of particle will be? Whenever it is crossing x-axis, x component will be there along x-axis, and the particle must have y component only, and the y component is v naught. So instead of that y-axis, let me call that as yz plane, so that will be easy for us. So this is what happens here. So when it is crossing x-axis, what will happen? The orientation, the velocity vector, the angle made by velocity vector with x-axis, it keeps on decreases. And what is the angle made by that is given by this formula. And what is further t, you should write nt. So this particular formula mv naught QE NT. Substitute n equal to 0, n equal to 1, 2, 3, 4. You can get the corresponding the angle. Now, some specific question I'll ask you. After what time the speed of particle will become 3 v naught? At t equals 0, the particle was having a speed v naught. After what time it will become 3 v naught? I'll straight away ask that condition. So here only, let me, I think I'll bring that question. It's available somewhere.